Tapping off the switch hot in the last light fixture in the road to supply power to the second Wattstopper TS400 override switch is generally acceptable. This practice is known as piggybacking and is typically employed to avoid running separate wires from the contactor to each switch. However, it is important to ensure that the wire size is adequate to carry the additional load. The method described for wiring the Wattstopper TS400 overrides in parallel is a common and acceptable approach. However, some electricians may prefer to run separate runs from the contactor to each switch and then out to the lighting load. This provides a more direct and dedicated path for power supply to each switch, which may be more reliable and easier to troubleshoot in the future. Ultimately, the best approach depends on the specific circumstances of the installation and the preferences of the electrician. Ensure that the contactor and TS400 overrides are compatible and rated for the load being controlled. Use appropriate wire sizes and types for all connections. Secure all wires and connections properly to prevent loose connections and potential hazards. Label all wires clearly for easy identification during servicing. Test the system thoroughly to ensure proper operation and safety. Tapping off the switch hot in the last light to supply the second TS400 override is acceptable and is a common practice to avoid running separate wires from the contactor. The cleanliness of the wiring depends on the electrician's preference and the specific installation. By following the appropriate guidelines and safety precautions, a reliable and functional control system for the lighting load can be ensured. When considering electrical wiring practices, especially those involving lighting control systems and devices like Wattstopper TS400 override switches, it's crucial to adhere to established electrical codes and safety standards. These standards, such as those outlined in the National Electrical Code, or NEC, provide detailed guidelines on acceptable wiring methods, conductor sizing, overcurrent protection, and grounding techniques. The NEC serves as a comprehensive resource for ensuring the safe and reliable installation of electrical systems. In this specific scenario involving the mechanically held contactor and the Wattstopper TS400 override switches, several key aspects warrant careful consideration. Firstly, the practice of tapping off the switched hot conductor in the last light fixture to supply power to the second TS400 switch, while generally acceptable, necessitates a thorough evaluation of the circuit's overall ampacity. Ampacity refers to the current carrying capacity of a conductor, and it must be sufficient to handle the combined load of all devices and fixtures connected to the circuit. This involves calculating the total current draw of the lighting load, as well as the current requirements of the TS400 switches. The wire size used for the switched hot conductor must be adequate to accommodate this total current without exceeding its ampacity rating. The NEC provides tables, such as Table 310.15b16, which specify the allowable ampacities of conductors based on their size, insulation type, and installation conditions. It is imperative to consult these tables and select a conductor size that meets or exceeds the calculated ampacity requirements. Furthermore, the overcurrent protection device, typically a circuit breaker or fuse, must be sized appropriately to protect the conductor from overloads and short circuits. The overcurrent protection device should be rated at or below the conductor's ampacity rating as specified in NEC section 240.4. In addition to conductor sizing and overcurrent protection, proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit in the event of a ground fault. All metal enclosures, such as light fixtures and junction boxes, must be properly grounded to prevent them from becoming energized and posing a shock hazard. Grounding conductors must be sized in accordance with NEC Table 250.122, which specifies the minimum size of grounding conductors based on the size of the ungrounded conductors. The cleanliness of the wiring installation is another important consideration. While the method described for wiring the TS400 switches in parallel is a common practice, running separate conductors from the contactor to each switch and then to the lighting load can offer several advantages. Firstly, separate runs provide a more direct and dedicated path for power supply to each switch, which can improve reliability and reduce the risk of voltage drop. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source, which can cause equipment to malfunction or operate inefficiently. Separate runs also simplify troubleshooting, as each switch and its associated wiring are isolated from the others. This makes it easier to identify and isolate faults in the system. However, running separate conductors can be more time-consuming and expensive, as it requires more wire and labor. The decision of whether to run separate conductors or use the piggybacking method depends on the specific circumstances of the installation, including the length of the runs, the complexity of the wiring, and the preferences of the electrician. Regardless of the wiring method used, it is essential to ensure that all connections are made properly and securely. Loose connections can cause arcing, overheating, and even fires. All wire terminations should be made using approved connectors and methods such as wire nuts, crimp connectors, or terminal blocks. The connectors should be properly sized for the conductors being used and should be tightened to the manufacturer's specifications. In addition to proper connections, it is important to secure all wires and cables to prevent them from becoming damaged or creating a tripping hazard. Wires and cables should be supported at regular intervals using cable ties, straps, or other approved methods. They should also be protected from physical damage by routing them away from sharp edges, moving parts, and areas where they could be subjected to impact. Labeling all wires and components is another important aspect of a clean and professional wiring installation. Labels make it easier to identify and troubleshoot the system in the future. All wires should be labeled with their circuit number, function, and destination. Components such as switches, contactors, and overcurrent protection devices should also be labeled with their function and rating. Before energizing the system, it is essential to test it thoroughly to ensure proper operation and safety. This includes testing the continuity of all circuits, verifying the voltage and current levels, and checking the operation of all devices. It is also important to perform a ground fault impedance test to ensure that the grounding system is functioning properly. If any problems are found during testing, they should be corrected before energizing the system. In summary, wiring a mechanically held contactor with Wattstopper TS400 override switches requires careful attention to detail and adherence to established electrical codes and safety standards. The practice of tapping off the switch-top conductor in the last light fixture to supply power to the second TS400 switch is generally acceptable, but it is important to ensure that the wire size is adequate to carry the additional load. The cleanliness of the wiring installation depends on the specific circumstances of the installation and the preferences of the electrician. Regardless of the wiring method used, it is essential to ensure that all connections are made properly and securely, that all wires and cables are supported and protected, and that the system is tested thoroughly before being energized. By following these guidelines, a reliable and functional lighting control system can be ensured. Remember that electrical work can be dangerous and should only be performed by qualified and licensed electricians. If you are not comfortable working with electricity, it is best to hire a professional to do the job. It is also crucial to consider the specific application and environment in which the lighting control system is being installed. For example, if the system is being installed in a damp or wet location, it is necessary to use waterproof or weather-resistant components and wiring methods. If the system is being installed in a hazardous location, such as a factory where flammable materials are present, it is necessary to use explosion-proof components and wiring methods. The NEC provides detailed requirements for electrical installations in various types of locations, and it is important to consult these requirements to ensure that the installation is safe and compliant. Furthermore, it is important to consider the long-term maintenance and operation of the lighting control system. The system should be designed and installed in a way that makes it easy to access and troubleshoot. All components should be clearly labeled, and a detailed wiring diagram should be provided. Regular inspections and maintenance should be performed to ensure that the system is operating properly and safely. This includes checking the condition of the wiring, connections, and components, and replacing any worn or damaged parts. By following these guidelines, the lifespan and reliability of the lighting control system can be extended, and the risk of electrical hazards can be minimized. When dealing with electrical systems, it's always best to err on the side of caution and consult with a qualified electrician if there are any questions or concerns. The electrical safety should always be the top priority. In addition to the technical aspects of wiring the contactor and switches, it's also important to consider the energy efficiency of the lighting system. Lighting can account for a significant portion of a building's energy consumption, so it's important to choose energy-efficient lighting fixtures and control strategies. LED lighting is a popular choice for energy-efficient lighting, as it consumes significantly less energy than traditional incandescent or fluorescent lighting. LED lighting also has a longer lifespan, which can reduce maintenance costs. In addition to using energy-efficient lighting fixtures, it's also important to use appropriate lighting controls. Occupancy sensors, which automatically turn lights on and off based on occupancy, can help to reduce energy consumption in areas that are not always occupied. Daylight harvesting systems, which automatically adjust the lighting levels based on the amount of natural light available, can also help to reduce energy consumption. By implementing energy-efficient lighting and control strategies, a building's energy consumption and operating costs can be significantly reduced. This can also help to reduce the building's environmental impact. Finally, it's important to document the electrical installation properly. This includes creating a detailed wiring diagram, labeling all components, and keeping records of all inspections and maintenance. Proper documentation makes it easier to troubleshoot the system in the future and ensures that it is maintained properly. It also helps to comply with electrical codes and regulations. In conclusion, wiring a mechanically held contactor with Wattstopper TS400 override switches involves several key considerations, including conductor sizing, overcurrent protection, grounding, wiring methods, connections, labeling, testing, and documentation. By following established electrical codes and safety standards, and by consulting with a qualified electrician, a reliable, functional, and safe lighting control system can be ensured.